Hi guys, in this video we're going to talk about electric force, what causes it, what makes it change, and what do you need to know about electric force. Now in a later video we're going to talk about this guy named Coulomb. Coulomb has a law, and Coulomb's law is about electric force. And the gist of it is this. Electric force is caused by charges. Electric force is due to charges. So you've already looked at static electricity. You've got some positive charges and some negative charges. Those are the charges that we're talking about. And those guys push on each other with electric forces. Now those electric forces depend on the charge, and I'm going to say of each because there's got to be two charges. And it also depends on how close they are. So the distance between them. So let's talk about that. Okay, so let's say this is going to be our spot here where we'll have our charges, and we've got some blue charges. Those will be our positives, and some red charges. Those will be our negatives. And we'll talk briefly about the atom. Those will be our they have neutrons in them too, and they don't have a charge, so they're white. Okay, so in an atom you've got your protons and your neutrons in the nucleus, and you've got some disproportionately large electrons floating around the outside. In chemistry you probably talked about what that looks like. We'll talk more about that in our unit about modern physics later on. But the neutrons don't have any charge, so they don't have any electric force here going on. There's something else. The protons, though, and the neutrons, or the protons and electrons, they do respond to each other. So this is a positive and this is a negative. When you have a positive and a negative, they attract each other, so these guys get pulled closer together. If you had two of the same charges, they repel each other. Whether it's positive or negative, they're going to go the opposite direction. So let's say we have a couple of things. I'm going to put a piece of paper down so I can write on it. Okay, so let's say we have a positive charge and another positive charge. Okay, these guys are going to be having forces pushing each other away, so I'm going to draw some arrows. Now Newton's third law says that for every action there's an equal and opposite reaction, so these forces are exactly the same. Okay, the forces on each charge are the same. Force on each charge is the same, and I'm going to capitalize same. Whoops, there we go. Same, okay? They are the same. They can't not be, okay? And we'll talk about that in a later video, okay? So what if, though, I had twice as much charge over here? Well, you might be thinking, well, there's more charge, so there has to be more force. So this arrow is going to get longer. But remember, the force on each has to be the same, so this arrow has to get longer also. In fact, if you have twice the charge, you will have twice the force. Okay? And that's just twice the charge on one. I haven't even changed this other thing. What happens if I do this? Well, now I have 4 times the charge. I have 2 times the charge over here, and I have 2 times the charge over here, and I'm just going to multiply those together. So I'm going to have 4 times the force. Now that might be kind of tricky. Perhaps if you saw the equation it might be a little bit easier. So there's an equation that shows us this relationship that we'll get to, and it says that the force is proportional to each charge. So we use Q to stand for the charge. So this maybe is Q1, and this maybe is Q2. So if I double this charge, you can see that I have a 2 there. And if I double the other charge, you can see that I have 2 Q's, and that's how I end up with the 4. So there's 4 times the charge, even though I only have twice, even though I have twice on both of those. Okay, so let's talk about another case. Positive or negative, the only difference there is if they're the same charge, they always push away, and if they're opposite charge, then they'll be pulling toward each other. So if I did the same thing, but with these guys instead, my arrows would just be pointing in. That would be the only difference. Okay? Now they're always going to point toward each other, so even if they're like this, then there would be an invisible line right here, and the forces would point along that line. Okay? So let's talk about the other thing that it depends on, and that is how far apart they are. So let's say we're here, and this guy is at 0, and this guy's at 5. Okay? So we'll call this distance r. R is a good word for distance. And there's some force on them. And now these guys, they're opposite charges, so they're going to be attracting each other. So maybe this is the amount of force that we have here. And again, the forces on both are the same, so pretend those arrows are exactly the same length. Okay? Now, what happens if I move it farther? And maybe now it's at 10. And so that's twice the distance as it used to be. Is it going to be pulling the same amount? Less? What do you think? Well, it is farther away, and just like it's harder to hear someone when they're farther away, this does in fact get smaller. Now, there used to be this really awesome app where you could measure these things, but we can't do that anymore. But if you remember anything about gravity, I don't know how much you learned about gravity, but gravity does this thing. It's called an inverse square law, where if you have if you double the distance, then you inverse that, so that would be half, and then you square it, so that would be a fourth. So at twice the distance, you have 1/4 of the force. That's called an inverse square law, inverse square. And it literally means it's proportional to 1 over the square of the distance. So that's how I got that 1/4. So this is my change. I square it and I stick 1 underneath it. Okay? So what if I go the other way, and instead of having it at twice the distance comparing to r, maybe I have it at half the distance. Okay? So maybe now I'm just going to move this up. So now I've got half r. Well, same idea. I'm going to inverse it, so I'll take 2, and then I got to square it, so I'll square it, and that gives me 4. So at half the distance, I have 4 times the force. Okay? So inverse square. Inverse it, then square it. And that is the change. Okay? So now that you know what happens to the force, you can easily think about what will happen to the objects. Because remember, Newton's second law says that more force means it accelerates more, less force accelerates less, and then there's a dependence on mass also. So you can think about what will happen to those charges too. But that is about it for electric force. In the next video, you will learn how to use that equation, and the whole equation, because we only talked about pieces of it. And then you can answer some more quantitative questions. Thanks for watching.